Hello, hello, and welcome to Gen Chem with Dr. J. I'm Dr. Janita Pritchett, and we'll be talking about all things chemistry related in these videos. On this video, we're going to learn all about density, what it is, and how we can use it to identify different substances. Let's get started. So, you've probably heard about the word density before, but we're really going to talk about what that property is and how we can utilize it to help us distinguish between different materials that may look very similar on the outside. Now, before we get into exactly what density is, I do want to talk about two different types of properties that we want to be able to familiarize ourselves with, because this is the principle behind why density is important. So one of the ways that we can categorize different properties is based off if they're considered to be intensive or extensive. Extensive properties are those properties that are dependent on the amount of the material that's present. So something like mass or volume. They're dependent on how much of that material is present. The more of something that I have, the mass is going to go up. The less of something I have, the mass will go down. But because I have two things that have similar masses, they may look similar, but the fact that I have two things of similar masses does not automatically mean that I have the same thing. All right, so the take-home message with extensive properties is, again, they are dependent on how much of the material are present, and we cannot use them for identification. It's simply a way of measuring how much is there, the quantity. Now, intensive properties are a little different. Those are those properties that their values are independent on how much is present. So regardless of how much of something that's there, that value remains the same. And so because it is independent of how much is there, we can actually use these properties for identification. So intensive I is independent I and can be used for identification I. So I. And so we know a lot of different intensive properties, things like the boiling point or the freezing point of water. Regardless of how much water we have, we always typically say that it's going to boil at 100 degrees Celsius and freeze at 0 degrees Celsius. So it's independent of how much is there. Well, these independent properties we can use now for identification. So it can really help us to rule out whether something is a particular substance based off of determining this particular intensive property. Now, both mass and volume, as I mentioned, are extensive properties. And these are the two main physical properties of matter. Now, they are extensive properties, which means they're going to vary as I change the amount of those substances that are present. However, when we look at the relationship between mass and volume together, what we see is that we get this linear relationship, this linear constant slope that exists between the relationship between the mass of a substance and its respective volume. Now, that consistent part, that slope, is what is going to be representing our density of an object. And so again, the intensive property is independent on how much is there because that relationship between the two things remains constant regardless how the amounts change. So again, density is the ratio of the mass to the volume of a particular substance. And we can see density represented in a number of units. Primarily in solids, you'll see the units represented as grams per centimeter cubed. And remember, we learned previously a centimeter cubed is the same thing as 1 milliliter. For liquids, you tend to see it written as grams per milliliter, and for gases as grams per liter. So it's typically written as a mass to volume ratio. So we can determine the volume a few ways. One is by doing direct measurements. If we have a nice geometric shaped type object, we can measure the length, the width, the height of a cube, or if we're dealing with a cylinder, we can measure the height and the diameter and subsequently get the radius and do a calculation in that manner. But if we're dealing with oblong or kind of odd shaped things, we can also determine the volume by doing displacement. And this displacement basically is based off of Archimedes' principle, which says that when you place a solid material into water, the water level will rise at the same amount that that object is taking up. And so if we measure the initial volume compared to the final volume, we can determine the volume of that substance. And so the formula that you want to remember as you're calculating density is that density is equal to mass divided by volume. As you can see, if we threw some units on here, so like let's say grams and milliliter, there's nothing canceling out. And so that's why our units for density remains as a gram to volume or gram to milliliter unit. One thing I always love to show my students, because you're going to want to be able to solve for any of these different variables, is this triangle idea. So this triangle is a really great tool that you can use for these 3 variable systems. And how you'll fill this out, you'll put the density unit here, the mass unit here, and your volume here. Now this line of your triangle represents a division sign. And this line of your triangle represents a multiplication sign. So when you're trying to solve for one of these variables, you simply cover up the thing that you're trying to solve, and then it tells you the resulting formula for that variable. So for instance, if I'm solving for density, if you cover that up like so, you get mass divided by volume as your equation. If you're solving for mass, we cover that up. What you're left with is density times volume. And if you're solving for volume, what you end up being left with If you're solving for volume, what you end up getting left with, cover that up, is the mass divided by the density. I like to show that triangle system to my students. They love it, using it as a learning tool. They can draw it right on their test whenever they start an exam, so I highly recommend using that system. And so again, density, it can be used for intensive properties. And so on this table here, you can see some densities of some common substances found at 20 degrees Celsius. And you can notice it's a wide range of things. Water being only 1 gram per centimeter cube, whereas platinum is something like 21.4 grams per centimeter cube. And so you can see this range that exists. So if you have some unknown material, if you can determine the mass of that object and the volume that it takes up, you can then calculate what the density is and confirm if indeed you have some pure material. Things to just keep in mind, that as you heat up an object, it does cause some shifting in the density. So just bear that in mind as you're doing any of your measurements. All right, let's try a problem. So you've just been given a platinum ring, or what your fiance says is a platinum ring, and you want to determine, is it indeed platinum? And so in our problem here, it says that we have this ring, and we've determined that its mass is 3.15 grams. And when placed in water, it displaces 0.233 centimeters cubed of water. We want to figure out, is this indeed platinum? And so although it's not explicitly saying it, what this problem is saying is that we need to calculate the density. And so we remember that density is equal to the mass divided by the volume. And we're going to plug in. Our density would be equal to the mass, which is 3.15 grams, divided by the volume of 0.233 centimeters cubed. Now, when we plug this into our calculators, we end up getting 13.5 grams per centimeter cubed. Now, if we look at our previous table, we see that platinum is actually 21.4 grams per centimeter cubed. So based off of this information, I don't think that this ring is indeed platinum. Okay, so that's how we can use it for identification purposes. Let's try another problem. So this problem says, what is the density of a brass sample if 100 grams added to a cylinder of water causes the water level to rise from 25 milliliters to 36.9 milliliters? So again, here we're asked to solve for the density. So density is equal to the mass divided by our volume. Now, when we look at the problem given to us, it's very easy to see what our mass is. It's 100 grams. But we got to be careful with what that volume is, because there's 2 different volumes technically listed. And so we want to make sure that we're selecting or putting in the proper volume. So what this is saying is that actually neither of those that are listed in the problem are the volume. What this is saying, I had this graduated cylinder, and it started with 25 milliliters of water. I then dropped in this brass cylinder, And that caused the water level to jet up to 36.9 milliliters. So the volume then is going to be represented by the difference between these two. We would take, so this would represent our initial volume and our final volume. So we would take our final volume minus our initial to figure out that volume. So we would take 36.9 milliliters minus 25.0 milliliters, and that's going to give us So we would take 36.9 milliliters minus 25 milliliters, and that's going to give us 11.9 milliliters. That's the number that we're going to be plugging into our equation to solve this problem. So we would take our mass, which is 100. So we would take our mass, which is 100 grams, divided by the 11.9 milliliters to solve our problem. So we would take 100 divided by 11.9, and that gets us 8.40 grams per milliliter, or we could also write this as grams per centimeter cubed because we're dealing with a solid material, remembering that 1 milliliter is equal to a centimeter cubed. This video helps you understand all about density, and look forward to hearing and seeing how you use this in the future. Stay tuned for more videos coming up. We'll see you next time. Bye.